You see those headlines all the time, right? This causes that. But have you ever stopped and thought, wait a minute, how do they actually know that? Well, today, we're going to pull back the curtain on quantitative research and see exactly how scientists build an airtight case to prove that one thing really does cause another. Let's start with a classic one. Does watching violent TV actually make kids more aggressive? You'd think it's a simple yes or no, but not so fast. To get a real scientific answer, you can't just go with a gut feeling. You've got to build a case with some serious, solid evidence. And that really is the key. It's all about building that airtight case. Seriously, think of it like a detective story. The researchers are the detectives, and they have a main suspect. In research, they call it the independent variable. For us, that's the violent TV. Their job, to prove beyond a shadow of a doubt that this suspect is the one who caused the outcome. So in this whole detective story of research, what's the golden rule? What's the one thing that makes their evidence stand up in court? It's a concept called validity. Okay, so validity isn't just one thing. It actually breaks down into two super important parts. First, you've got internal validity. This is all about what happened inside the study itself. Like for our example, did the violent TV actually cause the aggression in this specific group of kids? Then you've got external validity. This is the so what question. Do these results from the lab actually apply to other people, in other places, out in the real world? All right, let's dig into internal validity first. I love this analogy. Think of it as guarding the crime scene. The researcher has to be like a lead detective, putting up yellow tape to make sure nothing contaminates the evidence. They have to be absolutely sure that what they think happened is what really happened. Yeah, so at its heart, that's what internal validity is. It's about proving a true cause and effect link. The whole point is to rule out every other possible explanation, so you can point your finger at your one suspect and say, aha, you're the one, you're the culprit. But it's never that easy, is it? The detective's case is always at risk. It's under constant attack from the saboteurs. These are sneaky little factors that try to mess everything up, to confuse the results and make it look like something else was the real cause. And here they are, the usual suspects. Researchers have basically got a most wanted list of these saboteurs. You've got things like history, which is about outside events messing things up, maturation, which is just that people change over time naturally, and attrition, where people bail on the study. We're going to unmask a couple of the big ones right now, but just know, a really good research plan is designed to stop all of these guys in their tracks. All right, let's pull the mask off our first saboteur, history. And now, this isn't about what you learned in school. In research, history is any random, uncontrolled event that crashes your party, that happens during your study and messes with your results. It's a total intruder. Here's a perfect example. Imagine you're doing a study on how people feel about space travel. Everything's going great. Then, halfway through, a real-life spacecraft explodes. It's a huge news story. Well, you can bet people's attitudes are going to change, right? But it has absolutely nothing to do with your study. That's the history saboteur, just blowing up your results. Okay, next on the most wanted list is attrition. This is a fancy word for when people drop out of your study before it's done. And look, people dropping out happens. But the real problem, the thing that makes this a saboteur, is when the people who leave are different in some important way from the people who stay. Think about it like this. Say you're testing a new weight loss program. What if the people who have incredible success, they lose a ton of weight, drop out early because, hey, they met their goal, they're happy. But if you only look at the data from the people who stuck it out to the very end, your program is going to look like it barely works. Attrition just totally skewed your results. Okay, so let's say we did it. We guarded our crime scene, we fought off the saboteurs. We have strong internal validity. Awesome. But now comes the million-dollar question. Does any of this matter outside of our perfect little lab experiment? And that, my friends, is where external validity comes in. I mean, think about this for a second. So much research, especially in the past, was done on a very specific group of people, college students. Can we really take what we learn from a bunch of 19-year-olds in a university lab and say it applies to everyone? To grandparents, to people in different countries, to different cultures? That's the whole challenge of external validity. How far can you stretch your findings? And this leads to a huge dilemma for researchers, a real trade-off. The more you lock down your crime scene to get perfect internal validity, the more sterile and artificial your study becomes. It looks less and less like the real world. So sometimes you have to decide, is perfect control more important, or is getting a messy but realistic picture more important? It's a constant balancing act. So how on earth do researchers handle this balancing act? How do they build a case that's both solid on the inside and relevant on the outside? Well, they don't just wing it. They use blueprints. And in the world of research, these blueprints are called research designs. This chart lays it out perfectly. You can basically rank these blueprints by how strong they are. Down at the bottom, you have pre-experimental designs. Honestly, they're pretty weak, not many controls. A step up, you've got quasi-experimental. Getting better but still missing something crucial. And then, at the very top, the absolute gold standard for proving cause and effect, you have the true experimental designs. So yeah, that true experimental design is the one you want. It has a secret weapon, a real superpower, random assignment. What does that mean? It just means every single person in the study has an equal chance of being put in the group that gets the treatment or the group that doesn't. Why is that so powerful? Because it makes the groups basically identical from the get-go. And that is your best defense against most of those sneaky saboteurs. Let's just quickly walk through how one of these actually works. It's pretty straightforward. Step 1, you use that superpower, random assignment, to split people into 2 groups. Step 2, you test everyone to see where they're at before you do anything. That's your baseline. Step 3, you give the treatment, like watching the violent TV, to only one of the groups. Step 4, you test everyone again. And finally, step 5, you compare the after scores. If the group that got the treatment changed way more than the other group, boom, you have built a really, really strong case that X caused Y. Okay, we've covered a lot of ground. So what's the big idea here? What's the one thing you should remember? It really boils down to this. To prove anything in research, you need validity. You need to know your results are truthful. That means you need internal validity to be sure X caused Y inside your study, and you need external validity to be sure your findings actually mean something in the real world. And the way you get both? By using a strong research design, your blueprint for catching the real culprit and fending off all those saboteurs. So here's my challenge to you. The next time you see one of those headlines that says, "New study proves X causes Y," I want you to stop and think like a detective. Ask yourself, how strong is their case, really? Did they protect the evidence? And did they actually prove it beyond a reasonable doubt?